Hello everyone. In this clip I am going to show you the basics of a cost minimization in the long run when you can change both labor and capital. So you can check all these details in your textbook, but I think this explanation should be a good summary of what's going on here. So the first thing that you need to understand is this: total cost. R is the cost of capital and W is the cost of labor. So if you divide the total amount of cost by R, which is the cost of capital, let's say you are right here, you are going to get the number of units of capital that you can buy, the maximum number of units of capital that you can buy. In a similar way, if you divide the total cost by W, which is the cost of labor, you are going to get the maximum number of workers that you can hire. So if you connect these two dots, these two points, you are going to get what we call the isocost line, which is the combination of inputs, in this case K and L, that will cost the company the same amount. So it doesn't matter if you are here at point B or any other point on the blue line, is the same cost. Now, the slope of the isocost line, which is right here, is the ratio of the cost of labor by the cost of capital. This, in other words, is the relative prices of inputs. So this essentially is giving you the rate at which the market is going to let you substitute one for another, right? Now, let's talk about this curve right here, which we call the isoquant. The isoquant is, there is a typo here, as it's supposed to be a combination of inputs. The isoquant is the combination of inputs that produce a given amount of output. So in this case, you can have any combination of capital and labor that is going to give you a production of 100 units of output, right? Now, the slope of the isoquant, and in order to calculate this slope, you need calculus, so I will give you examples that don't require that. The slope is called the marginal rate of technical substitution, MRTS. This is the slope of the isoquant. This is the rate at which technically you can substitute capital for labor or vice versa while keeping the amount of output the same, right? So here is what all this idea boils down in terms of cost minimization. It can be shown mathematically, and I am going to skip the demonstration, of course. It can be shown that costs are going to be minimized when the slope of the isoquant is equal to the slope of the isocost line. In other words, when this relationship holds true, when the marginal rate of technical substitution equals the price ratio. Now, if you notice, this condition is only met once, here at point B. It is at point B where the slope of the isocost line is equal to the slope of the isoquant. This should give you the optimal amount of capital to hire, which you can call this K star, and the optimal amount of labor to hire. Because only at this point you can produce 100 units, which is what you want, minimizing cost and using the right combination of inputs. Now, think about this. Imagine that, you need to increase production. With this isocost, it means, what this isocost is telling you is that you cannot produce a point like this, or a point like this, or a point like this, or any point outside the isocost line. In fact, only you can produce some production level within the isocost line. The only way for you to produce a different level of output, let's say you want to produce a level of output C, where C, let's say, implies a production level of 200 units. Of course, this implies jumping from this isoquant, the blue one, to the green one, from Q0 to Q1. The only way you can do this is if you spend more money. In other words, rather than spending C2, you will have to spend C2, which of course implies hiring a larger amount of units of capital and hiring a larger amount of workers. So the point once again is that in order to minimize cost, these slopes, the slope of the isoquant and the slope of the isocost line, have to be equal, and this takes place only at, well, in the first case at point B, and once you increase production, this occurs at point C. I hope this clarifies a few things, and well, if you have questions, let me know.